Hello dear students, today we will start Standard 10 Physics. The name of the chapter is Light, that is chapter number 10. So here now we will see what are the topics we are going to cover in this chapter. So the first one is reflection. You might have covered reflection in your previous classes. Then we will see the laws of reflection of light. Then we will see spherical mirror. After that, the types of spherical mirror, that is concave mirror and convex mirror. Then certain terms related to spherical mirror like pool, center of curvature, radius of curvature, principal axis. Finally, we will see focus. What is focus? What is the relation of radius of curvature and focus? Then some miscellaneous points. And in the coming class, we will see image formation by a spherical mirror. So in today's class, we will cover till miscellaneous. Okay, so let us start the class without delaying it. So we'll start from reflection. You have already covered reflection and laws of reflection in your previous classes. So here, first point tells you about that an object reflects light that falls on it. Whenever a ray of light or a beam of light falls on an object, it gets reflected. Not always, it has to be an opaque object. See, depending upon whether the light is getting reflected by an object or not, the object is divided or categorized into three types. First one is opaque object. Second one is transparent object. Third one is translucent object. So in opaque object, what happens? Light get reflected. In transparent object, light passes through it. In translucent object, some part of the light get reflected and some portion will pass through that object. So suppose this is an object here, this is an object. Now this is a ray of light which falls on the object. If it is an opaque object, now this light will reflected back. This ray is known as incident ray. This ray is known as reflected ray. So when this reflected ray falls in our eye, suppose if I draw a diagram here, suppose this is here, a person is standing here. When this reflected ray falls on that person's eye, that person is able to see this object. Okay. So when received by our eyes, enable us to see things. We are able to see things, or we are able to see through a transparent medium as light is transmitted through it. So through an opaque object we are not able to see. We are able to see the opaque object, but we are not able to see what is behind the opaque object. Suppose this is an opaque object. Okay. A person is standing here. Okay. Another person is standing here. This first person cannot see second person. Why? Because this is an opaque object. Light cannot pass through it. On the other hand, suppose this is a transparent object or transparent medium, for example, a piece of glass. Then this person is able to see this person, or this person, that is second person, is able to see first person. Okay. Now light seems to travel in a straight line. So it is considered that light travels in a straight line from one point to another point. Okay. Now we'll see laws of reflection of light. There are two laws of reflection of light. You might have covered this one in your previous classes. Okay. So the first law is the angle of incident is equal to the angle of reflection. So what is angle of incident and angle of reflection? Let us see. Suppose we consider this as a mirror. Suppose this is a mirror. Now when a ray of light incident on the mirror or any opaque object, this is an incident ray, then it will get reflected back. Okay, as because the light ray cannot pass through the mirror, it will be reflected back, or it will reflect back. So angle of incidence, so at this point, this is the point of reflection. At this point, if you draw a perpendicular here, this perpendicular with respect to the mirror, this is known as normal. Okay, this is known as normal. Now this incident ray, this is reflected ray, this is normal. Here incident angle of incidence is this one, this angle between incident ray and the normal. It is known as angle of incident, which is represented by angle I. Now this angle, that is angle between normal and reflected ray, is known as angle of reflection, which is known as angle R. Now the first law tells you that angle of incidence is equal to the angle of reflection. So this angle and this angle both are equal to each other. So this one and this one. Okay. Now second law tells you that the incident ray, that is this ray, the normal to the mirror, here we have drawn the normal to the mirror, this one, at the point of incidence, this is the point of incidence, and the reflected ray, this is the reflected ray. See, this is the incident ray, this is the normal, this is the point of incidence, this is the reflected ray. All lie in the same plane. So these things will lie in the same plane. Okay. So this is the second law of light. Now spherical mirror. What is a spherical mirror? You must have known what is a sphere. For example, football, volleyball, all these are sphere. So this is a sphere. Spherical mirror, if you cut this sphere into two halves, one is smaller one is bigger one. The smaller one you will get. It shows you a spherical mirror. Okay, so how we will see. The reflecting surface of a spherical mirror may be curved inward or outward. Now see, here we consider a spherical mirror like this. See, this portion, this region is curved one. So we will consider this region as the seam. So the reflecting surface of a spherical mirror, consider this one as spherical mirror, may be curved inward. Now the light on which the light will fall either on this side of the mirror or this side of the mirror. So if the light will fall on this side of the mirror, then it is known as inward side. If the light will fall on this side, then it is known as outward side. Now this is the mirror. If light will fall here and it will get reflected back, then this type of mirror is known as concave mirror. Concave. Now see how it looks like. It is looking like a hole, like a cave. So you can easily remember this one. It looks like a cave. So this is concave mirror. On the other hand, if this side light rays falls and it gets reflected back, so this is known as outward side. Outward side. So this type of mirror is known as convex mirror. So this is concave mirror. That is inward side, looks like a cave. This is convex mirror. Okay. So a spherical mirror whose reflecting surface is curved inward, that is faced towards the center of the sphere, is called concave mirror. So this type is known as concave mirror. A spherical mirror whose reflecting surface is curved outward is called convex mirror. Now this is known as convex mirror. Okay. Here are the actual pictures of concave mirror and convex mirror. Here in case of concave mirror, here see, this is the reflecting surface. This outline I am drawing here, this one is the reflecting surface of the mirror. Okay. Now when a light ray falls here, it gets reflected back. Okay. So this is the concave mirror. In case of convex mirror, this is the reflecting surface of the convex mirror that I am doing this outline. So here, when the ray of light falls, it's get reflected back. Okay. Now this is the concave mirror and this is the convex mirror. Okay. Now there are certain terms related to mirror. So first one is pole. What is pole? The center of the reflecting surface of a spherical mirror is a point called the pole. So the center of the reflecting surface of a spherical mirror. Now if we go back to the diagram, now see here, you can see here that this is the concave mirror. Here if we take the middle point of it, this one, so this point is known as pole. For this mirror, this is known as pole, which is denoted by the letter P. This one is denoted by the letter P. On the other hand, in case of convex mirror also, the center portion, this one is known as pole, which is denoted by the letter P. Okay. It lies in the surface of the mirror. The pole is usually represented by the letter P, as I explained you just now. Now, next term is center of curvature. The reflecting surface of a spherical mirror forms a part of a sphere. This sphere has a center. This point is called center of curvature of the spherical mirror. It is represented by the letter C. So here, if we consider a spherical mirror, maybe concave, convex, whatever you can consider. Here I am considering concave mirror. You can also consider convex mirror. Now see, this curve looks like a part of a circle. Okay. Now, if you complete the circle, if you complete the circle, if you complete the circle, this is the center of the circle. Okay, center of the circle. Now this center of the circle is known as center of curvature. See, this is a curve. If you draw a circle out of this curve, the center, this point is known as center of curvature. Now, it is represented by the letter C. Now remember, this point is important, that it is not a part of the mirror. The center of curvature is not a part of this mirror. See, this is lying outside the mirror. Here, as I have taken this one concave mirror, here the incident ray will be from this side, from inward. Okay. Now for convex mirror, the diagram will be same. Okay. This is the center of curvature. This is the incident ray, and this will be the reflected ray. Okay. Sorry, here the ray will be inside, not outside. Correction here. the ray should be inside, it should not be outside. Here the ray should be outside, not inside. Okay. The third point is radius of curvature. Now here we saw what is center of curvature, what is pole. Now this is a mirror. Now this point is known as pole. This point is the center of curvature. If you join center of curvature and the pole, if you join center of curvature and the pole, it can be represented by radius of this curvature, which is represented by the letter r. So this is a curve. If you draw a circle out of it, this is the center of curvature, this is the pole. The radius of curvature is the line that joins center of curvature with the pole. Okay. Next one, principal axis. What is principal axis? Again we draw a mirror. This is a mirror. Now suppose this is the pole. This is the center of curvature. Okay. Principal axis is the axis or the line that joins center of curvature to the principal, to the pole. So it is the axis, or it is the line that passes through center of curvature and the pole. Okay, see, this is a line that passes through center of curvature and the pole. So as we are taking this line as a light ray, it cannot have two directions. That is why here I will erase this one. Okay. Again, why I have taken here this direction, not this direction? Because as I told you, in case of concave mirror, here this I am considering as a concave mirror. In case of concave mirror, the direction of ray of light is inward only. Okay. So principal axis is normal to the mirror at its pole. So this is the pole. At this pole, if I draw a normal here, normal means 90 degree. So at this point pole, the principal axis is normal to the pole. Okay, that means it is 90 degree. With pole, the angle of principal axis is 90 degree. Okay. Next point is focus. So what is focus? Let me explain you here. Then after that we will come to this diagram. What is focus? Now see, here, as I told you about the incident ray, suppose this is an incident ray. Whenever the incident ray incident on the mirror, then it gets reflected back. Okay. So focus is the point through which the reflected ray always pass. Okay, so this point is known as focus. See, this is the incident ray, this is the reflected ray. This reflected ray will pass the principal axis on a particular point. That point is known as focus. Okay. Now there are certain rules based on this. We'll talk about those rules in the coming classes. So here focus is the middle point between the center of curvature and the pole. Now this length between the focus and the pole, here it is known as focal length. Okay, f, small f. This one is focal length. Okay, so this is the center of curvature, this is the pole, this is the focus. Now the distance between focus and pole is known as focal length. Now see, as I told you that focus is the middle point between center of curvature and the pole. So this distance, that is FP, is equal to CF. Okay, but here distance between F and C, that is focus and center of curvature, is not considered as focal length. Okay, remember this one. Focal length is always considered as the distance between focus and pole. Okay, now focus is equal to 2 focus, that is radius of curvature is equal to 2 into focus. Now see, this is an object which is at infinity, this is a concave mirror, and these are the rays of light that are coming, and one is this one, another one is this one, another one is this one, another one is this one. These four rays of light are coming and incident at these different points. After incident, they are reflecting back and they are meeting at the same point. Okay, so this point is known as focus. This is the center of curvature, this is the pole, and this is focus. Now this distance between the focus and the principal axis, this distance is known as focal length. Okay, in case of convex mirror also, this object is at infinity, this is convex mirror. Here these incident ray will incident at different points of the mirror, they will get reflected back. After reflection, if we take the virtual image here, if we take the virtual ray, if you pull this reflected ray in the backward direction virtually, then they will pass through the focus. Okay, so here what happens, see, in case of concave mirror, the reflected ray are actually meeting at a certain point, that is focus. In case of convex mirror, the reflected ray are not actually meeting at certain point. Okay, here they are virtually meeting. So in case of concave mirror, real image is formed because images are really formed. In case of convex mirror, virtual image is formed. So about this image formation, we'll talk in the coming classes. Now about the miscellaneous, this point is really important, you should keep this one in mind. So this miscellaneous tells you that we generally consider that light always travels in a straight line. It is true, but in certain cases it does not holds good. This law does not hold good. But if an opaque object on the path of light becomes very small, light has a tendency to bend around it and not walk in a straight line. This effect known as the diffraction of light. Now, suppose this is a light ray. When there is an opaque object, it gets reflected back. Now, if the size of the opaque object is very small, minuscule, so here what happens, rather than reflecting back, light little bit bends its path and it will move. Okay, here light does not get reflected back, it bends itself, it bends its path and move. So earlier we studied that light always travel in a straight line. Here we studied that light is bending itself. Okay, so which fails the previous statement, which counters the previous statement. So why it is done, how it is done, what are the properties of light, about this one you will study in the 11th class. Okay, then a straight line treatment of optics using ray fields to explain phenomena such as diffraction. Now this is known as diffraction, the bending of light. Light is thought as of wave, and the detail which you will study in the higher classes, as I told you. About this property of light, about this diffraction, we'll study this one in higher classes. For now, you just remember that if the object is very small, that is minuscule, light has a tendency to bend itself and overcome the obstacle. Okay, so for now, this is the end of the class. In the coming class, we will start image formation by a spherical mirror. Thank you and have a nice day.